In this video, we'll be looking at some more examples of trig functions of non-acute angles. In this example, we're asked to find the exact value of each expression, and our first one is sine of negative 150 degrees. Now, if we sketch a graph of this angle, it's a negative angle, so it's going to move clockwise. So this is our negative 150 degrees. Our reference angle can be found by taking 180 minus 150. Our reference angle is 30 degrees. Mark that in here. Our reference triangle then is formed with one side on the x-axis, and the other side parallel to the y-axis, and our right angle is here. And we can see that we have a 30, 60, 90 triangle. So for convenience, we let our R value be 2, and then the side opposite the 30 is half of that, so it'll be 1. And then the side opposite the 60, this will be my 60, is the square root of 3. Now because this is left of the y-axis, it'll be a negative value for my x coordinate, and this one's down, so a negative value for my y coordinate. Now we know that sine is defined as y over r, or we can also think of it as opposite over hypotenuse. So in this case, our opposite side is negative 1, which is the y value, so negative 1 over, and the hypotenuse is 2. So this is the sine of negative 150. Do another one. Now 780 is more than one revolution, so let's find our coterminal angles. 780 minus 360 is 420, and subtract another revolution gives us 60 degrees. So our reference angle is going to be 60 degrees. So we can draw a sketch of this. 60 degrees is terminal side in quadrant 1. Our reference angle is 60. Our reference triangle has one side on the x-axis, the other side parallel to the y-axis, and here's my right angle. And again, for convenience, we'll let the hypotenuse be 2. The side opposite the 30, this is my 30 degree angle, is going to be half the hypotenuse, so it'll be 1. And the side opposite the 60 is half the hypotenuse times square root of 3, so this will be square root of 3. Now we know in quadrant 1 both the x and the y coordinates are positive, so I'm ready to find my cotangent ratio. I know that cotangent is the reciprocal of tangent. My tangent of this angle is root 3 over 1. So if I flip that over, find the reciprocal, I have 1 over root 3. Now we need to rationalize this denominator, and you do that by multiplying top and bottom by that radical. So we'll multiply numerator and denominator by root 3, and we get root 3 over 3. Let's do another problem. In this problem, we're asked to evaluate this expression. Now this first term, sine squared of 45, you may wish to write this as the sine of 45 squared. Usually it's written this way just because it's less writing, but what we're actually having to do is find the sine of 45 and then square that value. So let me write this one like that as well. This will be 3 times the cosine of 135 squared, and then minus 2 tangent 225. Alright, this reference angle is 45 degrees, and we know that that's our special triangle. We can put in our 1 root 2. We don't have to worry about signs on these because in quadrant 1 the x and the y coordinate are both positive. So the sine of 45, sine is y over r, so it'll be 1 over root 2. Then I have to square that value. Right, let me come along and do this next one. 135 has a terminal sign in quadrant 2. If we take 180 minus 135, we see that we have a reference angle of 45. Our reference triangle can be drawn here, and our 1 root 2 put in as the sides of our 45, 45, 90 triangle. Notice that on this one, since I'm going left, this needs to be a negative, and then up is positive. So this expression now, we have 3 times, and we need the cosine of this reference angle. Cosine is defined as adjacent over hypotenuse, so negative 1 over root 2 is what's getting squared there. And then on this one, 225. 225 is bigger than 180, so I'm coming around. My terminal side will be in quadrant 3. 225 subtract 180 gives me a reference angle of 45. I can draw my reference triangle and put in my signs, 1 root 2. Since I'm going left here, this will be a negative 1, and since I'm going down, this will also be a negative 1. So this expression now I need minus 2 times, and my tangent of this angle will be opposite over adjacent, so negative 1 over negative 1. Now if we square this, remember that when you square a fraction, you square the top and then square the bottom. So 1 squared is 1. Root 2 squared is 2. On this one, again, square the top, I get 1. Square root 2, I get 2. And then minus 2 times negative 1 divided by negative 1 is 1. So we have 1/2 plus 3/2 minus 2. 1/2 plus 3/2 is 4/2, which is 2 minus 2 is 0.